In this video, we'll take a look at the molecular geometry, also called the molecular shape for OCl2. And note that sometimes OCl2, it's written Cl2O. It's the same thing. This is actually a little more common, but the molecular geometry is going to be the same. So we look at our Lewis structure here, and we have two chlorine atoms. That's the Cl2, the oxygen in the center. But these right here, these are lone pairs, and they occupy space. They have volume, so they're going to repel just like the atoms do. We count up the things bonded to the central atom. 1, 2, 3, 4. That's our steric number. And remember, we have 1, 2, two lone pairs. That means we have a bent molecular geometry. So I want you to visualize how that happens. Visualize how these all repel each other to give us that bent molecular geometry. Pause and try that. Let's see what that looks like in 3D. So the oxygen, that'll be the purple central atom. Add one chlorine. Add another, they spread out. They push away from each other. When I add that lone pair, I put it right here. What's going to happen to these atoms here, the chlorines? They get pushed down. But we have two lone pairs. Push down even further, and that gives us the molecular geometry for OCl2. It's a bent molecular geometry. The key is these lone pairs, just like atoms, they occupy space, they have volume, and they influence the molecular geometry for molecules. Let's go back to our Lewis structure, and there's one more way we could do this. We could use the AXE notation. A is the central atom, the oxygen, we have two chlorine atoms, and E is the number of lone pairs, and we know that's important to the shape of the molecule. Two lone pairs. AX2E2, if you look that up, you have a bent molecular geometry. So now go to my video on molecular geometry to learn more about different molecular geometries and get some more practice. It's Dr. B. Thanks for watching.